Hello and welcome. I'm so glad you're here, whether you're curled up beneath a soft blanket, listening through quiet headphones, or letting your thoughts float as night gently folds around you. This space is just for you. A calm place where your mind can stretch out unhurried and explore big, beautiful things in soft, sleepy ways. Tonight, we're going to begin a journey. A journey not through space, but through time, or perhaps around it. Now, I should gently warn you, this might get a little too fascinating. We'll try to keep things calm, rhythmic, meditative, but time has a way of pulling us in. So if you find yourself still awake, don't worry. The mind drifts in its own time, and sometimes curiosity makes the best lullaby. Before we begin, if you're enjoying this moment already, I'd be so grateful if you gave this video a gentle like, shared it with someone who also loves cozy science, and maybe even subscribed for more bedtime explorations like this. And if you'd like to leave a comment, I love seeing where you're listening from and what time it is for you. A quiet map of sleepy minds, lit softly across the globe. And for those who feel extra generous, a super thanks means more than you know. It helps keep this space glowing. Now, settle in, let your breathing slow just a little, let your thoughts come softly apart, and let's begin. You lie still and yet time moves all around you. Your body doesn't go anywhere, the room doesn't change, and yet a second becomes a second becomes a second, and something is happening. The world continues invisibly, unspooling. You don't have to do anything for time to pass, it just does. But what is time? Not what clocks measure. Not just numbers or calendars or ringing alarms, not just the hands of a wristwatch or the blinking of a phone. Time is deeper than those things. More like an atmosphere. More like a rhythm beneath everything, more like the pulse of the universe. For a long time, people imagined time as a river, flowing in one direction, always forward. That's still how we talk about it. Flowing time, lost time, time slipping away. But what if that picture isn't quite right? What if time isn't flowing like water, but stretching like a blanket drawn gently across a bed? Or rippling like wind across silk? This is where we begin, with a new shape for time. A shape you can't touch, but you can feel. A shape that isn't fixed, but shifts depending on where you are, or how fast you're going, or how massive the world around you is. Imagine lying on a trampoline, soft and dark. You place a heavy ball in the center. The surface sags. It curves. Now imagine a marble rolling across it. The marble's path bends, not because of a string or a push, but because the fabric beneath it is no longer flat. This is space and time. This is space-time. What we used to think of as separate, space over here, time over there, are actually woven together, like threads in a tapestry. Where the weave tightens, time slows. Where it stretches, time quickens. Mass bends this fabric, so does speed. And you, moving through it, feel time not as a river, but as a landscape. So what happens when you move faster? Or stand near something more massive? Time bends, time stretches, time dilates. And this gentle stretch, is what scientists call time dilation. It doesn't mean time is breaking, it just means it's behaving differently for different travellers. Someone flying past at incredible speed will experience time more slowly than someone standing still. Not because their clocks are wrong, but because time itself is moving differently for each of them. And this isn't just theory. It's been tested, measured, felt. Astronauts in orbit return a little younger than they would have on Earth. Not enough to notice, just microseconds, but still younger, because time for them passed just a little slower. Even now, the clocks on GPS satellites, the ones helping your phone tell you where you are ticking just slightly faster than the ones on the ground. Why? Because they're farther from Earth's mass. And gravity, it turns out, also bends time. It's as if the closer you are to a heavy object, like Earth, the slower your clock runs. Your feet right now are aging more slowly than your head, only by a billionth of a second, but still different. Strange? Yes, but also kind of beautiful. It means time isn't the same for everyone. It depends on where you are, on how fast you're going, on how much mass surrounds you. Time isn't one fixed beat, but a music that changes with the movement of the players. And if time can stretch, can we stretch with it? Could you travel forward in time by simply moving fast enough? Could you, like some cosmic traveller, go far away and come back younger than your friends? In theory, yes. You don't need a time machine, just speed, or gravity, or a way to bend space so strongly that time ripples like a pond disturbed by a falling star. But tonight, you don't need to go anywhere, because this story, this shape of time, it's already stretching around you, in the stillness of your breath, in the softness of your thoughts, in the distance between stars. Close your eyes if you haven't already. Let your body sink into the surface beneath you. Feel how the world holds you, how gravity pulls you gently toward the Earth's centre. And with that pull, time slows for you, ever so slightly. You're already part of this stretching, bending universe. Let the shape of time cradle you like a hammock between stars. And as you drift, you may begin to wonder, if your body is part of time's fabric, then could your body also be a clock? You rest quietly now, somewhere between waking and sleep. The mind begins to let go of the day, the noise, the light, the constant reaching. The air is still, the body is heavy, and yet, within you, things are ticking. You may not hear them, but you are full of clocks, soft ones, subtle ones. Clocks made not of gears and hands, but of pulses, patterns and breath. Listen to yourself, just for a moment. Feel the rise and fall of your chest, the hush of your breath as it enters and leaves. That rhythm, it is time. It is your time. Now place your hand gently over your heart. Can you feel it? Each beat is a second, maybe less, maybe more, but it is steady, an old, faithful drum keeping your body's tempo. Even if you lie perfectly still, even if you fall asleep, your body continues counting. Your heart is a timekeeper, so are your lungs, so is your brain. And deeper still, each cell in your body runs on timing, knowing when to divide, when to rest, when to sleep, and when to wake. These rhythms are known as biological clocks. Not clocks you carry, but clocks you are. One of the most important of these clocks lives deep in your brain, in a place called the suprachiasmatic nucleus, a tiny bundle of nerve cells, about the size of a grain of rice, quietly watching the light around you, marking the passage of day and night. This little cluster is your body's master timekeeper. It syncs your sleep, your hormones, your hunger, your alertness. It's why you feel tired at night, and why you wake in the morning, even without an alarm. But the master clock is not alone. Each of your organs, or your liver, your stomach, your muscles, holds its own internal timer. They all tick together, a choir of rhythms, and when they fall out of sync, when you fly across time zones or stay up too late, you feel it. Jet lag, brain fog, a sense of unease. That's your clocks arguing. Your body doesn't just experience time, it keeps it. Let's go smaller now. Down, down, past the organs into the cells themselves. Every living cell has its own rhythm. Tiny molecular cycles spinning and stopping, marking the rise and fall of proteins, energy, and life. And deeper still, in the atoms that make you, electrons shift energy states in perfect predictable intervals. These transitions, measured with incredible precision, form the foundation of the most accurate clocks ever built. Atomic clocks. That's right. The atoms in your body do what the best science in the world does. They count time by rhythm, by cycles, by dance. Even time itself, the world of physics, is defined by these oscillations. 1 second is the time it takes for a cesium atom to vibrate 9,192,6170 times. So time isn't something separate from you, it's not just a ticking clock on a distant wall. Time is something you carry, something your body sings. You are, in a real and beautiful way, a living clock. And just like the clocks on satellites or space stations, your internal clocks are sensitive, not just to light, but to motion, speed, and gravity. Time dilation, which we began to explore earlier, doesn't just apply to metal and machines. It applies to you. If you were to climb a tall mountain, even just a few kilometers high, your body would age ever so slightly faster than someone at sea level. Not enough to notice, but enough to measure. Your clock would be ticking more quickly simply because you're farther from the Earth's pull. And if you were to travel at incredible speeds, the kind only reached in space, your body would slow down, relatively speaking. Your clocks, your cells, your heartbeat, your very aging processes would gently pause compared to someone standing still. This is real, measurable, proven. And it means this: time is not separate from biology. It flows through it, is shaped by it, is part of it. Even your dreams have rhythm. They move in cycles, light sleep, deep sleep, dreaming sleep. Round and around every 90 minutes or so, like a tide washing through your brain. This rhythm matters. It's when your mind processes memory, files emotion, clears space. And it depends, like everything else in your body, on timing. When your internal clocks are in harmony, you feel well. You feel awake in the day and sleepy at night. You heal more quickly, you think more clearly. Even your mood balances gently. You're not just alive in time, you're tuned to it. And when those rhythms fall out of sync, your body feels lost. Your mind becomes foggy. Illness can rise more easily. The clocks are still ticking, but not together. Fortunately, they can be reset. Light, especially morning light, is a powerful tool. So is rest, so is routine. Your body, though incredibly complex, responds to small, simple patterns. A warm meal, quiet bedtime, a soft light dimming at dusk. These are the lullabies your body listens for. You're a timekeeper, but also a listener. And the universe, through light, gravity and rhythm, is always speaking. So tonight, as you drift into sleep, your body is still counting. Quietly, comfortably. Each heartbeat a gentle tick. Each breath a soft reminder that you are moving through time in your own perfect way. And tomorrow, when you wake, you will be slightly older, but also slightly renewed. You are time's companion, its rhythm, its reflection. Now, if your body is a clock, what happens to that clock when it moves faster? Or falls into deeper gravity? Could speed, could gravity change how your time feels? Somewhere in the hush between your thoughts a question forms, not urgent but curious. How do we know that time can stretch or slow or bend? To understand, we must float backward, not through time exactly, but through stories. Back to a quiet desk, a rumpled young man, and a question that no one else thought to ask. Albert Einstein. You've heard his name, maybe you picture wild hair, chalk dust, or swirling equations. But let's soften the image. Let's imagine him not as a genius with formulas, but as a thinker with wonder, a dreamer who dared to sit with silence long enough for time to speak. It began not with math, but with a question, a simple one. Einstein asked, if I were riding alongside a beam of light, what would I see? This wasn't idle play. It was his way of holding the universe gently in his hands, turning it over, asking it to reveal itself. Thought experiments, he called them. Quiet journeys the mind could take when the body stayed still. Let's take that journey with him. Close your eyes if you haven't already. Imagine you're on a train gliding smoothly across the countryside. You look out the window. The world passes by, slowly, steadily. Now, a storm brews on the horizon. A flash of lightning strikes both ends of the train at once, one at the front, one at the back. If you are sitting exactly in the middle and the flashes reach your eyes at the same moment, you might think they happen simultaneously. But what about the person standing outside the train, watching from the platform? To them, the train is moving forward. The flash at the front of the train is moving away from them. The one at the back is moving toward them. So they might say, no, the lightning didn't strike at the same time. The flash at the back reached you first because the train was moving toward it. The front flash was chasing the train. Who's right? Einstein's answer, and this is the part that changed the world, is that both observers are right. That time itself is relative to the observer. There is no single, universal now. What feels like the same moment to you may not be the same for someone else. Not because of illusion, not because of error, but because time is woven with space and both depend on your point of view. That's the heart of Einstein's special theory of relativity, a theory born not in a lab, but in a gentle, deliberate act of imagination. And here is where the poetry begins. If time isn't absolute, if it can change depending on motion, then all those little clocks we carry, all those rhythms in our body and the universe, tick at different speeds for different travellers. You walking slowly across the room experience time just a tiny bit differently than someone running. And someone in a spacecraft near the speed of light experiences time more slowly than someone on Earth. This is not science fiction. This is science fact, confirmed again and again through experiment and precision and patience. But it started with dreams, with wonder, with soft hands turning ideas over and over like stones from the shore. Einstein's hands, they didn't grab at truth. They didn't rush, they cradled questions until the answers felt ready to arrive. He imagined clocks on moving spaceships. He imagined beams of light bouncing between mirrors. He imagined twins, one travelling near light speed, the other staying behind, and what would happen when they reunited. He imagined again and again what no one else dared to. And what he found was astonishing. The faster you move, the slower time moves for you. Not your perception of time, actual time. The rhythm of your atoms, the aging of your cells, the flicker of your thoughts, all slowed down from the point of view of someone watching you from outside. You wouldn't notice anything strange. You would feel normal, natural, steady. But when you returned, you might find the world older. Your friends aged, the clock's ahead. You, the traveller, have stepped into the future. And all of this, from one question: what does light still see? Tonight, in your rest, let yourself ride that beam of light. Imagine moving so fast that time begins to stretch behind you like silk. Imagine space itself folding slightly around your speed. The stars begin to blur. The seconds tick slower, not just in feeling, in truth. Light always moves at the same speed, no matter who watches it. That's another one of Einstein's discoveries. It is the constant, the unwavering messenger. And because it is constant, everything else, space, time, mass, must adjust around it. We once thought space and time were separate, but Einstein showed us that they are threads in the same fabric, bending and swaying together. And like a fabric, they can stretch. They must stretch, to make room for the speed of light, the gravity of stars, the curious motion of minds. Einstein didn't make the universe stranger, he made it clearer. He held up a mirror and showed us how it really works. And in doing so, he opened the door to time travel, and not through magic or machines, but through motion and mass. He showed that time is not a ruler, not a ticking metronome, but a dancer. Graceful, responsive, shaped by what surrounds it. And you, listening here, still and quiet, are part of that dance. Your time may feel steady, but under the surface it flows in curves, in slow ripples, in quiet bends, and just like Einstein's train, or his beam of light, your experience of time depends on your motion, your gravity, your view. So rest here, in the curve of time. Let it hold you. And as you do, you may begin to wonder, if speed can slow time, what else can? What if something even gentler, like gravity, could change the tempo of your life? You are still. The body rests, and the breath moves like a tide, gentle, sure, and slow. But now let your thoughts begin to move. Let your imagination lift from the ground and start to drift, slowly at first, like a leaf caught in the breeze. We are going somewhere tonight, not in space, but in motion. And in motion, something beautiful happens. Time begins to change. In the quiet of your mind, picture yourself on a ship, not one of wood or steel, but of soft light and quiet humming engines. This ship doesn't sail across oceans. It glides through space, growing faster and faster, past clouds of stars, past glowing dust, past the slow whirl of galaxies. With every increase in speed, something subtle shifts. At first, you hardly notice it. Your heartbeat feels the same. Your body moves as it always has. But outside your window, the world begins to change. The stars blur as if smeared gently by a painter's brush. The ticking of the universe, the constant rhythm of seconds and minutes, begins to stretch. Not because your ship is faulty, not because you're dreaming, but because the laws of reality, the rules of motion and time allow it. Time moves more slowly for you now. You are still you still feel the seconds, but compared to someone left behind, someone waiting on Earth, your seconds have changed shape. They've grown longer, stretched gently like warm taffy in the sun. This is time dilation, brought on by speed, and it's real. This isn't a poetic metaphor. It's physics, measured, confirmed, repeated. The faster you move through space, the slower you move through time, at least relative to those who stay still. Imagine two friends, one stays on Earth, the other boards your lightspeed ship. Years pass. When the traveller returns, something astonishing has happened. They are younger than the one who stayed behind. Not in memory, not in illusion, truly younger. Time moved more slowly for them. This is not just a thought experiment anymore. We've seen the effect quietly in real life. Muons, tiny particles born in the upper atmosphere, live only fractions of a second before decaying. At rest, they disappear almost instantly. But when they move fast, when they race toward the Earth at nearly the speed of light, their lives stretch. They live longer, travel farther. Not because they've changed, but because time, for them, has changed. Even astronauts, orbiting Earth at high speeds, experience this. Their clocks run ever so slightly slower than ours, not enough to notice, but enough to measure. After months aboard the International Space Station, they come home just a bit younger than if they had stayed grounded. These differences are tiny for us now, but if we could go faster, much faster, the effect would grow. At speeds close to light, the world outside your ship could age thousands of years while you drift through only a few. You wouldn't feel any different. Time from your view would be smooth and normal, but when you returned, everything would have changed. What a strange and gentle power, to move forward in time simply by going fast. But there's a cost. To reach those speeds requires immense energy. Moving near the speed of light isn't just difficult, it approaches impossibility. The closer you get to light speed, the more your mass increases, the more energy it takes to move just a little faster. Light itself, that gentle, constant traveller, always moves at the same speed. No matter what you do, you cannot catch up. You can run, you can chase, you can fly, but light will always move ahead, always at 299,792,458 meters per second. So you drift in its wake, just a little behind. But even that motion, even that striving slows time for you. And what is this, really, but a kind of time travel? Not the kind with buttons or dials or glowing tunnels, but real physical time travel through motion. Speed reshapes your experience of time, and in doing so it reveals something quietly profound, that time is not a fixed thing, it's not universal, it's not shared evenly. Time is personal. Your journey, your movement, your mass, they shape your clock. No two people live exactly the same second. So tonight, as you lie still and the world turns slowly around you, remember, you are already a traveller. A soft, slow traveller through time. You do not need a spaceship to bend time. You're already moving, on Earth's rotation, on its orbit around the sun, on the galaxy's spiral through space. You're already caught in motion, already bending time by simply existing. And as you sleep, your atoms remember. They keep their rhythm. They spin and hum and whisper across the fabric of space-time, not quickly, not loudly, but in perfect synchrony with the universe's strange and beautiful clock. So let yourself slow now. Let your heartbeat become the only ticking you notice. Let the idea of speed fade, and instead imagine stillness. The kind of stillness found not in empty space, but in the deep pull of something larger, heavier, more ancient. What if motion isn't the only way to stretch time? What if gravity, soft, silent, always pulling, could bend time too? You're lying still now, resting, breathing, drifting. The world feels level, quiet, grounded. And yet beneath you something powerful pulls, something ancient, silent and invisible. Gravity. You feel it all the time, though you rarely think about it. It holds you to your bed, keeps your feet on the earth, draws the oceans toward the moon. It is the most familiar force, and one of the most mysterious. Tonight, let's lean into that pull, gently. Let's feel how gravity doesn't just hold us down, it holds time too. Close your eyes if you haven't already. Imagine your body resting, the earth gently cradling your weight. Now imagine a clock placed by your feet, and another one just above your head. They tick together, almost perfectly, but not quite. Strange as it sounds, the clock at your feet runs a little slower. Why? Because gravity, soft and constant as it is, bends time. The deeper you are in a gravitational field, the closer you are to the centre of mass, the slower time passes for you. This phenomenon is called gravitational time dilation. Even here, on the surface of Earth, the effect is measurable. In 2010, physicists at the National Institute of Standards and Technology in Colorado placed two atomic clocks just 33 centimetres apart, one slightly higher than the other. The result? The lower clock ticked ever so slightly more slowly. Not a difference you'd ever notice. But it's real, confirmed, counted, felt by the atoms themselves. Imagine now walking up a mountain. With every step upward, gravity's pull lessens. Just a little. Time in response speeds up, and just a little. When you reach the peak, your clock has moved slightly ahead of someone who stayed at sea level. You have stepped into a future just a few nanoseconds away. It's a strange thought, isn't it? That just by climbing you change your time. That altitude, that elevation, gently reshapes your experience of the universe's rhythm. But gravity's effect on time becomes truly profound when we leave Earth behind. Let's go deeper now, much deeper. Imagine a black hole, a collapsed star with so much mass, so much gravity, that not even light can escape its pull. The space around it curves steeply, and time in the grip of that gravity begins to stretch. As you drift toward the edge of the black hole, the event horizon, your time slows, more and more. To an outside observer, you appear to freeze, suspended at the edge, caught in a moment that never ends. But from your own point of view, time continues. Steady, soft, normal. You fall inward. Light bends, reality tilts, time slows near massive objects because space itself is curved, and because time is woven with space, it must bend too. The deeper the well of gravity, the deeper the pool of time. This isn't just theoretical, it's the foundation of general relativity, Einstein's deeper theory of gravity. When Newton saw gravity as a force, Einstein saw it as geometry. Mass tells space how to curve, space tells objects how to move, and time follows the shape of that space. Imagine laying a heavy ball on a rubber sheet. The sheet sags. Now roll a marble near the ball. It curves inward, spiraling. That's how planets orbit stars. Not because they're pulled by invisible strings, but because they follow the curves of space. And time moving through that same sheet stretches near the mass. The heavier the object, the more it slows the passage of time nearby. On Earth, this effect is subtle, but around a black hole it becomes extreme. In the film Interstellar, this concept was brought to life. A planet orbiting close to a black hole experienced time so slowly that an hour on the surface was equal to 7 years outside. It's science fiction, yes, but rooted in science fact. You don't need a spaceship to feel it, though. Right now, lying where you are, you're already caught in gravity's arms. You're already living in curved space, already aging differently than you would if you floated higher above the Earth. And your body responds in ways it doesn't even notice. Your heart, your bones, your cells, all tuned to gravity's gentle hum. Sleep itself may be shaped by this pull, not just in the way we lie down, but in the way time flows around us. When you dream, you enter a world where seconds feel elastic. A moment can last forever. An hour can vanish. Could it be that part of that sensation comes from your body's quiet relationship with gravity? No one knows for sure. But what we do know is this. Gravity is not just a force. It is a sculptor, a weaver, a patient hand that molds the path of time. And the more mass we place in space, stars, planets, galaxies, black holes, the more the fabric bends, and the more time shifts. You're not just living in time, you're living through its curves. You're closer to the center of the Earth than the clouds. And so your seconds move more slowly. It's as if your dreams are resting in a deeper part of time's ocean. Quieter, slower, heavier. And so you sleep, not in one universal flow, but in your own soft stream. As you breathe and dream and drift, time is not marching forward, it is curling gently around you. And now, perhaps, you begin to see a larger picture. If time can bend with speed and stretch with gravity, then what happens when both are combined? What if two people lived two very different lives, one travelling, one staying home? What would happen when they meet again? Settle in again, just as you are. Let your shoulders soften, your breath flow gently in and out. Let the room grow quiet, the air still. Tonight's story is about two people, two twins, identical, and yet destined to experience time very differently. Let's begin with a simple picture. Two siblings, born at the same moment. They grow up together, laugh together, wonder about the stars together. One day they stand at a launch pad. One twin boards a spacecraft, the other stays on Earth. The ship will travel fast, very fast, near the speed of light. And though it seems like a thought experiment, it is grounded in real physics, real equations, real possibilities. As the ship lifts off, the twins wave. They are still the same age. But the moment the ship begins to accelerate, their experiences begin to drift apart. The travelling twin feels normal, weightless, focused, perhaps awestruck by the stars outside the window. Time flows as always. Heartbeats continue. Meals come and go. But from Earth's perspective, something strange begins to unfold. The clocks on the ship, every tick, every second, begin to move more slowly. From the Earth twins' viewpoint, their sibling is aging at a different rate, and the longer the journey continues, the more dramatic the difference becomes. Imagine 20 years passing on Earth. The twin who stayed has grown older, wrinkles softening the edges of the eyes, hair touched by time. But for the traveller, only a few years have passed. Their face is nearly unchanged. their body still young. When they return, the contrast is unmistakable. The twins stand side by side again, but one has lived through far more time than the other. This isn't fiction, it's the twin paradox, a famous scenario in the theory of special relativity. At first glance it seems impossible. How can time split between two people? How can they meet again and be out of sync? The answer lies in motion. Remember, speed slows time. When one twin moves at high velocity, especially speeds approaching light, time dilates for them. The very structure of space and time bends to accommodate the motion. The paradox only appears if we forget the role of acceleration. The twin on Earth never changed speed, but the travelling twin did, accelerating to leave, decelerating to return. That change in motion breaks the symmetry and causes the divergence in time. And this is not just theory. Experiments using particles called muons and synchronized atomic clocks flown on airplanes confirm it. Time really does behave this way. We've measured the difference. But beyond the math and the data, there's something deeply emotional about this idea. Two people born together, forever linked. And yet they experience time differently, not because of choice, but because of physics. It invites a soft kind of grief, doesn't it? To know that even time, the thing we thought we shared most deeply, can part ways between those we love. And yet, there's wonder too. Imagine what the travelling twin has seen. Galaxies curving through black space, nebulae blooming like watercolour clouds, the quiet hum of motion, the hush of deep space, all while time from Earth's view stretches onward. The twin who stayed has lived a life with roots, walks in the woods, tea with old friends, seasons turning. And when they reunite, they bring their timelines together again. A moment of reunion that spans two separate rhythms of the universe. So tonight, close your eyes and imagine being both twins. You are the traveller, moving so quickly that time itself slows for you. And you're also the one who stays, watching stars shift in the sky, feeling the years pass in your bones. Both lives are real. Both are valid. Both are part of this strange and generous universe. And perhaps, just perhaps, we are always both. Our memories move slowly, our emotions race. The mind can stretch a second into a whole day. A dream can last hours in the space of a breath. Time is never just one thing. So maybe the twin paradox is more than a scientific puzzle. Maybe it's a mirror of something deeper. That we all live in different time zones of feeling. That we all return to those we love changed, aged, different. Not because something went wrong, but because that's the nature of time itself. And if that's true, then every reunion is a small kind of time travel, a moment where timelines meet again, not perfectly, but meaningfully. So let yourself rest now in that meeting place. Let your body relax, your breath grow slow, and imagine the softness of those two clocks, ticking differently, yet both carrying you forward. And now, as you drift even deeper into sleep, another question floats gently in. What if those tiny differences in time, the ones caused by motion and mass, were happening all the time, in machines, in satellites, in the invisible sky above? High above you, beyond the clouds, beyond the drifting air currents, a quiet constellation of machines glides through space. They circle the Earth not for beauty, not for science alone, but for something so simple, so everyday, finding out where you are. These are GPS satellites, global positioning system. Your phone speaks to them silently, constantly, and without them your maps would wander, your directions would lose their way, you would drift, not far, but far enough. But what makes this system truly extraordinary is not the technology, it's the timing. Each GPS satellite carries a clock, an atomic clock, beating with exquisite precision. Billions of oscillations per second, more steady than the sunrise, more faithful than any machine we've built. These clocks are the heart of navigation. Your phone listens to at least 4 satellites at once, measuring how long it takes each signal to arrive. With that information, a difference of mere nanoseconds, it triangulates your position, where you are, exactly, in this moment. But here's the quiet complication. These satellites are far from Earth, about 20,000 kilometers above us, and they're fast, moving at over 14,000 kilometers per hour. And as you now know, speed slows time. Gravity changes it. Because they are moving quickly, time aboard the satellites ticks more slowly from our perspective on the ground. This is special relativity in action. But, because they are also farther from Earth's mass, they feel less gravity, and in less gravity, time ticks more quickly. This is general relativity, so two effects, one slows the clocks, one speeds them up, and they don't cancel out. When we calculate them together, the clocks on GPS satellites tick about 38 microseconds faster per day than clocks on Earth. That may not sound like much, just 38 millionths of a second, but in GPS that's enormous. If we didn't correct for this time dilation, if we didn't adjust the system using Einstein's equations, our position would drift. By kilometres. Every single day. Your phone would think you were in the wrong city. Your car might drive through a forest instead of a street. Planes would lose their course, maps would melt into chaos. So every GPS satellite uses time corrections born from relativity, born from Einstein. He never held a smartphone. He never programmed a satellite. And yet his quiet thought experiments, the trains, the beams of light, the bending of time, are now part of our daily lives. Each time you check your location, each time a map loads, you are using relativistic time dilation. What once seemed like abstract theory, like dreams scribbled on blackboards, has become the scaffolding beneath our footsteps. It's easy to forget, isn't it, that the ordinary can rest upon the extraordinary, that your phone, your pocket, your hands, carry within them a constant conversation with space and time. Let's float up now, let your imagination drift with me, gently rising through the atmosphere, past the clouds, past the weather, into the blue curve of the sky. There they are, satellites, sleek and silent, each one locked in its orbit, each one circling in perfect rhythm, beaming down their time. They do not know what time is, but they keep it better than we ever could. They sing their seconds into space, and far below your phone listens, and by listening it knows where it stands. This is one of the most delicate dances ever devised, technology and physics and starlight and signal all working together to tell you, you are here. What a marvel, and what a quiet reminder, that time is not a constant drumbeat, not one rhythm for all. The clocks above us drift, because gravity and speed have their say, but we adjust, we listen, we correct, and in doing so we find our place again. So tonight, as you lie here, let yourself feel just a little of that cosmic coordination. Let yourself imagine all those clocks, high above, ticking a little too fast, and all the scientists, engineers, and silent equations working gently to bring them back in sync with you. And if something so vast, so fast, so high can bend time and still find its way, then so can you. Perhaps time is not a fixed path, but something we tune to, like a radio station, like a heartbeat. And if light keeps that rhythm steady, what is light anyway? Why is it always the same no matter how fast we move? Light always arrives on time, not early, not late, not sometimes fast, sometimes slow, just constant. It is the heartbeat of the cosmos, a rhythm against which all other rhythms are compared. And tonight, as you lie still and your breath slows, we'll follow a single thread of light on its journey through the fabric of space, and through the secrets of time itself. Let your thoughts drift upward again, and past the satellites, past the clouds, into a space where darkness isn't empty but full of movement. Here, imagine a photon, a single particle of light. No mass, no rest, no hesitation. It moves at 299,792,458 meters per second. That number isn't a guess. It's not approximate. It's exact, because we don't measure light speed. We define it. By agreement, by science, by deep understanding, the speed of light is the ruler by which space and time are measured. And here's the wonder. No matter how fast you move, no matter where you are, no matter what direction you chase it, you can never catch light. Its speed remains the same to all observers. Even if you race alongside it in a spaceship, it still moves away from you at the exact same pace. This is the mystery Einstein sat with. This is what led to time dilation, length contraction, and the realization that space and time are not separate things, but intertwined. Because if the speed of light is always constant, something else must give way. And what gives is time. Let's return to our photon. It leaves a distant star, perhaps millions of years ago, and travels toward Earth. Across cold space, past drifting clouds of gas, past the gravity of galaxies. It never slows, never stops, never grows tired. And though it has no mass, it carries energy. It warms your skin, it paints colours, it brings information from across the universe. But here's something almost impossible to imagine. From the photon's perspective, no time passes at all, because it moves at light speed, and at that speed time for it doesn't flow, or the moment it's created and the moment it arrives are one. It exists outside time as we understand it. This is hard for our minds to hold. We are creatures made of seconds. We grow, we remember, we age. But light just moves. It is a messenger between worlds, carrying not just energy but knowledge. When you see a star, you're seeing the past, because that light took time to reach you. If the star is 100 light years away, you're seeing it as it was 100 years ago. Its present remains hidden. You're always catching up. Light defines what we can know and when we can know it. But it also gives us a ruler, a steady, unchanging beat against which we can measure all movement. Scientists use lasers, beams of light, to measure the tiniest distances. They use light bouncing between mirrors to detect the stretching of space itself from distant black hole collisions. And time, atomic clocks, the most precise in the world, are based on how atoms absorb and emit light. They use light's consistency to mark the passing of each perfect second. So when we speak of time dilation, or GPS corrections, or the twin paradox, we are really talking about the constancy of light. It is the one thing that does not bend, even as everything around it does. And that creates the bending, because if light refuses to change, then time must. And space must. It's as if the universe chose one constant melody, and let every other instrument adjust around it. Light is not just illumination. It's information. It's structure. It's the scaffolding of reality. Even in the deepest sleep, your eyes closed, your body still, your body is tuned to light. Your circadian rhythm, your internal clock, is guided by sunrise and sunset. Even the smallest hint of dawn through your eyelids can tell your body, begin again. Your cells sense the shift. Your hormones adjust. Your thoughts stretch into morning. And at night, as now, your body welcomes darkness, a pause in the rhythm, a soft note held between light's chorus. So tonight, as you rest, you are part of that music. Not just observing it, but made of it. Your atoms, your vision, your memories, they are shaped by light. You are not outside the rhythm. You are within it. And just as the speed of light is constant, so is its invitation to understand, to measure, to reflect, to wonder. But if light moves without aging and time slows with motion, what happens when we travel back to where time began? Not where light is travelling to, but where light was first born. What did the universe look like in the beginning? What was time before there were stars? Close your eyes if they aren't already. Feel the hush that surrounds you now, not Satan's exactly, but something deeper, a softness without edges, a stillness without time. Tonight we drift back, not just through years or centuries, but to the very beginning, to a moment before moments, to the birth of time itself. It begins with a breath that wasn't yet breath, a spark that wasn't yet light, a universe that wasn't yet anything but a singular point, impossibly dense, impossibly hot. A place where all that would ever exist was packed into something the size of nothing. And then, without warning, without some sound, without cause we can name, it began. The Big Bang. Not an explosion in space, but the expansion of space itself. In an instant, the universe unfurled. It didn't push into emptiness. It created the emptiness as it went. Time began here. Before that, there was no before. Not because it's hidden, but because the idea of before did not yet exist. Time as we know it, sequence, duration, rhythm, started with the cosmos itself. It didn't tick into motion like a clock striking one. It swelled, expanded, stretched. Not a drumbeat, but a rising tone. Not a hallway, but a horizon. And with it came space, and with space movement, and with movement change. Change is the root of time. Without change there is nothing to measure. So as the newborn universe stretched outward, temperature dropped, energy cooled, and in those first fractions of a second, particles formed. Protons, neutrons, electrons, the seeds of all matter, suspended in a sea of light too thick to escape. For 380,000 years this early universe was opaque, a glowing fog where photons bounced endlessly off particles, unable to travel freely. But then something shifted. Atoms formed. And suddenly, light could move. This moment, this freeing of light, is called recombination, the moment when the universe became transparent. And the light released then is still with us. We can see it, instruments tuned to the hum of the cosmos. It comes not in bright colour, but in microwave whispers. We call it the cosmic microwave background, a soft glow from all directions, older than stars, older than galaxies. It is the afterglow of creation, a memory of time's first breath. And in that light, scientists have found a map, a record of what the universe looked like when it was just 380,000 years old. Ripples, temperature variations, tiny differences that would, over billions of years, become galaxies, stars, planets. Us, or even now, as you rest, as you lie here listening, you are wrapped in that ancient light. It drifts around you, through you, older than Earth, older than atoms. This means you are not separate from time's beginning. You're made of it. The hydrogen in your body, the most abundant element in the universe, was formed within minutes of the Big Bang. Your atoms carry the fingerprint of that first unfolding. You are, in every way, a child of that ancient moment. And what a comfort that is, to know that you belong not just to Earth, not just to now, but to a story that began when time itself was born. And this story continues. The universe is still expanding, space is still stretching, galaxies drift farther apart, and time, like space, keeps unfolding. But unlike a tape or a thread, it doesn't unwind in one direction only. It carries echoes of its past into every second. You feel it when you see the stars, when you hold warmth from sunlight that left the sun 8 minutes ago, when you remember a voice from a dream or a day long gone. Even now, in this moment of stillness, you are part of the expansion. Your body moves with the Earth, which moves with the sun, which orbits the galaxy, which rushes through the fabric of the cosmos, stretching time as it goes. And if time began with the universe, does that mean it could end? Could there be a moment when time itself fades back into stillness? When the stars dim, and space grows cold, and change slows to nothing? We don't know. Some theories whisper yes. Some say time may ripple forever, carried endlessly on darker energy's breath. Others imagine a great contraction, the universe folding back in on itself, a final heartbeat in the dark. But tonight, you don't need to reach the end. It's enough to know that time had a beginning, and that your breath, your heartbeat, your thoughts are part of that same unfolding. You are not outside of time. You are shaped by it, held by it, cradled in its long, slow arms. And now, as you sink even deeper, your body wrapped in gravity, your mind adrift in gentle motion, you may begin to wonder. If time began so long ago, and light carries that memory forward, then even small changes in elevation, even a walk uphill, might stretch your time just a little. Tonight let's take a quiet walk. Not hurried, not steep, just a slow, thoughtful climb up the side of a mountain, a path winding gently upward, through thinning air and soft wind. Each step not only lifts your body, but lifts your time, because here's something strange and true. When you rise above the earth, even by a little, time moves faster. It's not a trick, it's not a glitch, it's relativity, playing softly in the background. Let's imagine two clocks. One rests at sea level, the other placed gently atop a mountaintop observatory. Both are precise, atomic, steady, designed to measure time down to the billionth of a second. And yet, they disagree. The one above ticks faster, not because it's faulty, but because it's higher, farther from Earth's centre of mass, farther from gravity's strongest grip. You see, gravity pulls not just on your body, but on time itself. The deeper you are in a gravitational field, the slower your time flows. So by lifting the clock, we're loosening gravity's hold, and with that lightening, time stretches subtly. At the summit, you are aging just a tiny bit faster than someone standing at the base. Your seconds are longer, your clock is freer. This has been tested not just with mountain clocks, but with satellites and airplanes, with hikers and physicists. Even the difference between the ground floor and the top floor of a tall building is enough to shift time by measurable amounts. Tiny differences, but very real. Let's sit now halfway up our mountain. The air is cool and thin, the stars feel closer. and down below the valley lights flicker like embers in a great hearth. Here, your thoughts feel lighter too, not just because of the altitude, but because you've stepped into a slightly different flow of time. Time is never completely the same from one place to another. It's like a river that narrows and widens, ripples and rests. Even when you don't feel it, the shape of the land beneath shapes the water's flow. And here on this slope, you're walking along time's ridge. You may not notice it with your senses, but the atoms in your body do. They tick a little more freely. They swing in slightly wider arcs. You are, in this moment, a traveller between seconds. This idea might feel too small to matter, microseconds, nanoseconds, but imagine stretching those small differences over long years, or over extreme landscapes. Now picture a black hole at the base of a vast cliff, and a distant star at the top. Their clocks would not agree. In fact, near enough to a black hole, time could almost stop, while far above it flows on swift, unbothered. That same principle applies here, just more gently. The mountain is no black hole, but it still shapes time. And there's something poetic about that, isn't there? That your position in space affects your passage through time. That climbing, lifting, rising all change your pace, even if your feet feel tired. There's also something tender about the Earth's pull. Gravity holds you, not with force, but with presence. It gathers you to the centre. And in that gathering, time slows. Maybe that's why mountain air feels different, why thoughts drift easier, why dreams feel more vivid. Maybe the difference is too small to name, but not too small to feel. Sit here with that thought a moment. You are right now closer to the stars, farther from the centre of the earth, a little freer, a little faster, not in movement, but in time. And down below, in the valleys, others sleep. Their seconds curl a bit more tightly, their clocks beat in a slightly slower rhythm. And still, we are all part of the same world, all held by the same fabric, all walking the same road, though the tempo changes with every step of elevation. Imagine now climbing higher, past the tree line, past the snow, to a point where only sky surrounds you. At the very top you breathe more deeply, and not just because of the view, but because you feel lighter, and your time flows just a little more quickly, not fast enough to see, but enough to mean something to the atoms in your bones. And now you may begin to wonder, if time stretches with height and bends with whole mass, then what happens when you fall towards something so heavy, so deep that time itself nearly stops? What happens when you dream your way toward a black hole? Let your breath be slow. Let your thoughts loosen like a ribbon slipping from a breeze. Tonight we're falling, not in fear, not in danger, but into a deeper softness, a kind of quiet gravity. Tonight we drift toward a black hole, not with urgency, not with panic, but with curiosity, with wonder, and with trust that time, even here, holds us gently. A black hole begins as something ordinary, a star burning bright, its light warming distant worlds. But even stars must die, and for the most massive among them, death becomes something astonishing. When the fuel runs out, there's nothing left to hold the star up. Gravity wins, and the star collapses inward, its core folding tighter and tighter, until it vanishes into a point of unimaginable density, a singularity, and around it forms a boundary, the event horizon, a line not of light or matter, but of no return. Beyond this horizon, even light cannot escape, not because the black hole grabs it, but because space itself is falling inward. Imagine a waterfall, a river flowing gently until it reaches a place where the current quickens, then faster still, then so swift nothing can swim back up. The event horizon is that point of no return, but instead of water, it's space, and instead of swimming, it's light. Now imagine you're falling toward this black hole, not too fast, just drifting, peacefully. From your own point of view, nothing feels strange. You check your watch, it ticks normally. Your heart beats its steady rhythm. But to someone watching from far away, a friend perhaps, floating at a safe distance, everything about your fall seems to slow. Your movements stretch, your gestures delay. Even the light from your face grows redder, fainter. As you near the event horizon to your distant friend, you appear to freeze, frozen in time on the edge of forever. This is gravitational time dilation at its most extreme. The black hole's mass bends space so deeply that time itself slows near it, and at the very edge, time stops completely. From the outside perspective, inside the event horizon, all paths lead inward. Every direction is down, not down in space, but down in time. You're no longer moving through space in time, you're moving through time as space collapses around you. Strange? Yes, but also deeply beautiful, because even in the shadow of a black hole relativity holds. The rules remain. The universe is consistent even at its strangest edges. But let's return to you now, falling peacefully, slowly toward the horizon. You're not afraid. This is not a fall of fear, but of awe. You pass through strange light, twisting stars, space folded like soft fabric around you. Perhaps you see distant galaxies curved into halos. Perhaps you hear the slow echo of time, drawn out like a deep breath held forever. And the closer you fall, the slower your time runs, until from the outside it nearly stops. But you don't feel it, because your time, your inner clock, ticks as it always has. This is one of the most extraordinary truths of physics. There is no single time, no one clock that rules them all. Time is local, time is personal. Time bends to the space it travels through, and in the curved space of a black hole, that bending becomes infinite. Now imagine resting there, just above the event horizon, not crossing but floating just shy of the edge. You would see the universe in fast forward, stars spinning rapidly, galaxies aging before your eyes, centuries passing in minutes. You would be near timelessness, a stillness so deep the cosmos seems to race without you. And from far away you would appear forever caught in descent, a dream that never ends, a motion frozen in the amber of gravity. That's what makes black holes so dreamlike. They're not just dense, not just dark, but distorted. They are places where time folds, where space stretches, where the familiar rules bend into a softer shape. And as you drift in sleep tonight, you're not so far from that feeling. Your body lies still, your breath slows, your thoughts stretch into stories. Time loosens its grip. This is your own kind of horizon, a personal event horizon, the edge of waking, the beginning of dream. And just like the traveller near the black hole, you're entering a place where time behaves differently, where minutes become hours or vanish altogether. And as you fall into that soft inner space, you may wonder, if time slows near great gravity and stops at the edge of a black hole, what does that mean for the dreams you dream there? Could your mind drift differently through time just as your body does in motion? What happens inside you when your own time shifts? Sleep comes softly now. You've floated past the edge of the waking world, where thoughts loosen and reality becomes pliable, like warm clay in the hands of your resting mind. In this place, this drifting space, time feels different. It stretches and folds. A moment becomes an hour disappears like mist. Tonight, we explore what happens to time inside you when your eyes close and your mind begins to dream. Because even here, deep in the folds of sleep, you are still a clock. But the ticking changes. Let's begin inside the brain, not as a diagram or a machine, but as a sea, a shimmering field of electrical waves, rising and falling in rhythmic cycles. These waves shift as you sleep. Alpha waves give way to theta, then to the long, slow pulses of delta. Your brain slides into deeper waters, where dreams begin to drift toward you. And here's the first wonder. These changes in brain rhythm correspond to changes in your experience of time. During REM sleep, the stage where vivid dreaming occurs, your brain is almost as active as when you're awake. But the sense of time in dreams is slippery. You've felt it, haven't you? A dream that seemed to last hours, yet when you wake, only minutes have passed. Or the opposite, a flash of a sudden scene that fills you with memory but seems to have taken no time at all. This is not imagination. It's perception, shaped by internal rhythm. You see, your experience of time is not only ruled by clocks and gravity, it is shaped by how your brain processes change. And dreaming is full of change. Surreal jumps in location, sudden emotional downturns, impossible actions. Your dreaming brain isn't bound by the same logic it follows when awake. And without consistent sensory input, no sun, no footsteps, no ticking seconds, time becomes something fluid, shaped by the story you're inside. Researchers have studied this. They've asked lucid dreamers, people who know they're dreaming, to count seconds while dreaming. to perform simple tasks inside the dream. And what they found is fascinating. Time in dreams often moves slower. Not always, but often. A simple action like raising a hand might take longer inside a dream than in waking life. Your brain is still keeping time, but differently, in a softer, more elastic way. Now let's go even deeper. Imagine your brain as a garden. Each neuron a tree, each connection a path. In waking life, your paths are well travelled. You walk them quickly, retracing familiar loops, but in dreams, new paths open. Old ones twist. The garden grows wild. Your sense of time depends on how far you wander, how much you notice, how deeply you feel. And in dreams, you feel deeply. A single image can carry the weight of a memory. A single phrase can echo like a bell. This emotional intensity can make time feel longer, just as boredom makes time crawl and excitement makes it fly. So even when your body is still, your mind is moving through time, not in hours or minutes, but in story. And yet while you dream, your internal biological clocks keep ticking. Your heart slows, your body cools, your cells continue their rhythms. You're adrift, but not lost. Time keeps watch over your sleep, and the longer you remain asleep, the more your body follows a rhythm, circling through stages, 90 minutes at a time, like a spiral staircase winding gently downward, then up again toward waking. You pass through this cycle 4, 5, 6 times a night, and with each turn REM sleep deepens. Dreams lengthen. Your stories grow more vivid as the morning nears. Time, even in dreaming, has structure. And yet, it doesn't feel that way, because memory doesn't record dreams in seconds. It holds on to moments, a face, a sound, a feeling. You might wake with the sensation of having been somewhere far away, of having lived a full day or travelled across years, all within the span of half an hour. Your dreaming mind does not measure time by clocks. It measures by emotion. It measures by how deeply you've wandered into yourself. And what does this tell us? That time, as we feel it, is not only external, it lives in perception, in memory, in rhythm, and in that way dreams are a kind of time travel, not to distant futures, but to versions of the present your waking mind could not see. So as you rest now, floating between cycles, know this. Even here, even now, you are in time. You are of time, but your path through it is softer than a line. It curves, it slows, it carries you like a wave across the sea of sleep. And as you float, a new thought begins to rise. If dreams move differently through time, if even neurons can drift in rhythm, then what would it mean to find a place in the universe where time doesn't move at all? There is a moment, just as you begin to fall asleep, where time seems to pause. Not because it ends, but because you've stopped holding it. It slips from your hands. Your breath continues, your heart moves, but your awareness of time, that quiet metronome in the back of the mind, vanishes. Tonight, we linger in that in-between space. We ask a gentle question. Could the universe contain places or moments where time doesn't flow at all? Not just slower, but truly still. Not broken, not undone, just paused. To imagine this, we first have to ask what time really does. Time, in the language of physics, is what lets change happen. It allows cause to become effect. It lets energy shift. It gives motion a direction. Without time, nothing changes. So where might we find such stillness? Let's begin small, microscopic, atomic. In certain quantum systems, particles exist in what's called a ground state, their lowest possible energy level. No spare motion, no thermal jitter. A kind of perfect rest. In a Bose-Einstein condensate, atoms are cooled to temperatures barely above absolute zero. At this point, they begin to behave not as individual particles, but as one single quantum entity. And in this cold silence, something extraordinary happens. Change nearly stops. Atoms that usually jitter and spin become calm, almost motionless, as if the clock they follow has slowed to a crawl. In this extreme cold, the energy needed to create change simply isn't present. Does this mean time has stopped? Not exactly, but in such systems, there is no change to observe, and when nothing changes, time becomes unmeasurable. It's not gone, it's just invisible. Think of it like floating in a perfectly still lake, no ripples, no breeze. If your body doesn't move, if your mind is silent, how would you know time is passing? You wouldn't, until something changes. A splash, a breeze, a thought. Now let's zoom outward. Some physicists suggest that in the very earliest moments of the universe, before particles, before light, time may not have existed in any meaningful way, only a timeless quantum state, a pure possibility, no before, no after, just a kind of presence like holding your breath before the leap. Others look into the depths of black holes, wondering if beyond the event horizon, time continues as we know it, or if it halts completely at the singularity's edge. The closer you approach the singularity, the more extreme the curvature of space, the more warped time becomes. At the very centre, our physics no longer speaks clearly. We run out of language. It may be timeless, but it may also be something else entirely, a region where time takes on a form we haven't yet imagined. And there are more speculative ideas still, that time at the quantum level might not be continuous at all, but come in tiny indivisible units, like pixels on a screen. Planck time, the smallest possible unit of time, 5.39 us 10 to 44 seconds. Below this scale, the idea of before and after breaks down. Time might not be a smooth line. It might tick, click, blink. Even the present moment you feel right now might be a kind of shimmer, not a single point, but a tiny window, a blur, not a dot. And that blur might flicker with moments of stillness woven between motion. Just like you, sometimes still, sometimes waking, sometimes dreaming. Timelessness doesn't mean absence, it means potential. A canvas not yet touched, a page not yet turned. And even in the stillest systems, like cold atoms or early universes, change can return, with heat, with interaction, with observation. The moment time begins again is the moment something moves. So perhaps timeless places are not gone or unreachable, but simply waiting, resting, cradling the next note in the melody of motion. And now, as you rest, you may feel a bit like one of those quiet atoms, energy low, movement minimal, thoughts barely shifting, not frozen, but paused. And in that pause, you find peace. It's not that time has stopped, it's that you're no longer chasing it. You're letting it drift past like clouds while you remain anchored in the space between seconds. You are for now your own ground state, your own quantum stillness. And from that place, you may begin to wonder. If time can hide inside atoms and pause inside black holes and blink beneath the surface of everything, then could we bring time to a halt on purpose? Could scientists in quiet laboratories actually slow time down in real measurable ways? The night is still now. The stars are far above, but down below, in quiet windowless rooms, under soft lights and steady hums, another kind of universe is being explored. Not through telescopes, not through spaceflight, but through precision, tiny experiments, unshakable patience, and the delicate measurement of time itself. Because time dilation, that strange poetic bending of time with speed or gravity, is not only theory. It's real, it's measurable, and it's been seen, not in dreams, but in laboratories. Let's step into one now, not as a scientist, but as a quiet visitor. The room is cool, the walls are thick. There's a rhythm here, but it's not a ticking clock. It's the hum of machinery and the pulse of invisible seconds being stretched. Here, researchers work with muons, tiny subatomic particles born high in Earth's atmosphere when cosmic rays strike atoms. Muons decay quickly. They live just 2.2 microseconds, barely enough time to blink. At rest, they vanish almost instantly. But when they move fast, very fast, something remarkable happens. They live longer. Not because they change, but because time for them changes. In experiments, muons travelling near light speed reach detectors on Earth's surface far more often than expected. Because in their frame of reference, time moves more slowly. They live more seconds, not by resisting decay, but by riding a different rhythm of time. And this is how we see time dilation. Directly, repeatedly, predictably, but we don't need cosmic particles to prove it. We've done it with machines, with flying clocks, with atoms in carefully controlled chambers. One famous experiment happened in the 1970s. Physicists flew highly precise atomic clocks on commercial airplanes around the Earth, once eastward, once westward. They compared the time on these clocks to those left on the ground. And just as Einstein predicted, the clocks disagreed. By billionths of a second, minuscule, but measurable. the moving clocks ticked slower, and when adjusted for altitude, for the change in gravity, the numbers made perfect sense, both special and general relativity working together. Time, as seen from the lab, really does bend. And now, let's visit an even quieter space. A place where scientists cool atoms to near absolute zero, creating optical lattice clocks so precise they would lose only 1 second every 30 billion years. These clocks are so sensitive they can detect time moving differently over a distance of just centimetres. Place one clock just slightly higher than the other, and their rhythms fall out of sync, not from error, but from gravity. It's like watching time ripple in a bowl of still water. Gentle, exact, unavoidable. The more we refine our tools, the more clearly we hear the quiet song of time stretching. It's not dramatic, it's not loud, but it's there, and it reminds us what we thought was fixed is fluid. What we thought was singular is personal. Even now, researchers continue to test time at finer and finer scales, building clocks so precise they can detect the slowing of time in your head versus your feet, or in your breath versus your stillness. And these measurements, so small, are beginning to shape the future. Time dilation isn't just curiosity, it's foundation. It keeps GPS systems accurate. It opens doors to deep space travel. It challenges how we think about aging and motion, and what it means to exist in a universe that refuses to keep perfect tempo. And yet, for all this science, for all this ether and precision, there's something quietly poetic in these results. That our world, beneath all its noise, moves in rhythms we can barely feel. That when we fly or climb or rest beside a massive object, our bodies shift their tempo ever so slightly. That the universe pays attention to every step. Tonight, as you lie still, you are not moving fast. You are not far from Earth's surface. But even here, your body is responding to the invisible curves of space and time. Your cells tick their own rhythms. Your atoms feel the planet's pull. You are a biological experiment, proof that time doesn't just pass, it responds. And so you rest inside a story that science is still writing. A story of seconds that stretch and slow and shimmer. And just as the lab can show us time's softness, it also invites another question. If we can stretch time forward, travel into the future by motion or mass, then what about the past? Can we return? Or does time, like a river, flow only one way? Let your body sink a little deeper now. Feel the bed hold you, the earth hold the bed, and gravity wrap around all of it like a soft, invisible blanket. You are still. But your mind drifts forward into a question as old as wonder itself. Can you visit the future? Not through magic, not with spinning machines or glowing portals, but through the quiet, natural laws of the universe, through time itself. The answer, softly, surprisingly, is yes. You can. And the path is already written, not in fantasy, but in the very equations of physics. Einstein showed us the way. You felt it in earlier chapters, when speed stretches time, when gravity slows it. Now imagine combining both. Imagine a ship, not loud, not clumsy, but smooth and silent, sliding through the black between stars. A ship moving fast. Not just highway fast, not even rocket fast, but relativistic, a fraction of light speed. You climb aboard, wave goodbye, and begin to travel. Days pass for you, maybe weeks, but when you return, Earth has changed. 10 years, 50, 100. Your friends have aged, your city is new, children have grown, the world has turned, and you have moved forward in time. Truly, physically, you've skipped ahead, that's the wonder. You didn't speed up your life. You slowed down your own time compared to the world you left behind. You weren't asleep, you weren't frozen. You were simply taking a slower road through time. This is real time travel, one direction only. No paradoxes, no loops, just the rhythm of relativity. We already know it works. Astronauts experience it just a little. Satellites experience it measurably. And if we had ships fast enough, strong enough, time travel into the future wouldn't just be possible, it would be expected. But even here on Earth, you do it every day. Every second you spend at rest lets someone on a mountain age slightly faster. Every time a GPS satellite circles overhead, its clocks tick just a bit differently from yours. The future is not a place you have to find, it's a place you're already approaching. The question is only, how fast do you want to get there? And if motion is one path forward, then gravity is another. We've seen this too. Place yourself near something incredibly massive, a neutron star, a black hole, and your time will slow compared to the universe around you. You could, in theory, spend an hour near such an object, then return to find centuries passed. Time once again becomes pliable, it responds, but there's something gentle in this idea. You're not breaking time, you're flowing with it, on a slower current, while the rest of the river rushes by. And when you rejoin it, you've stepped into a later chapter of the same story. So yes, you can visit the future. But you can't choose which future you'll find. You can't steer it, only arrive in it. And once there, you can't go back. Because unlike space, which lets you move freely in all directions, time, as far as we can tell, flows in only one. Forward. That one-way motion is something physicists call the arrow of time, and we'll explore that in the next chapter. And for now, let this idea cradle you. That time travel is not a fantasy, it is a feature, built into the universe's design, and you are already doing it. Every breath, every heartbeat is a tiny step into the future. You don't need a spaceship, you don't need a formula. You are travelling forward right now, and still, the question stirs softly in the background. If forward travel is real, why can't we go the other way? What is it that keeps the past forever behind us? Why do eggs not uncrack? Why do stars not undie? Why is the past so beautifully, irreversibly gone? Tonight you lie quietly, cradled in softness, eyes closed or slowly blinking. The world has grown still, but time as always moves. Always forward, never back. But why? You can walk in any direction. North or south, east or west, or umtus. You can turn around, reverse course, return to your starting point. But in time, you can only go one way. You can remember, but not re-enter. You can replay, but not relive. The past stays behind, and the future waits ahead. This gentle one-way motion, this quiet current that carries all things forward, is what scientists call the arrow of time. It is not made of ticking clocks. It is made of change, and more specifically, of entropy. Entropy is a word that sounds complicated, but it simply means this: disorder. Or more poetically, the natural tendency of things to fall apart. Imagine an egg. You hold it in your hand, whole, balanced, smooth. A simple, organised thing. Now drop it, it breaks. Not because you want it to, but because that's the easier path. The shell scatters, the yolk runs. The system moves from order to disorder. Could it unbreak? Not realistically. Not because it's impossible in physics, but because it's so unlikely that the chance of it happening is vanishingly close to zero. That's entropy. Left alone, systems tend to spread out. Heat disperses, paint peels, memories fade, time flows in the direction where entropy increases, and that direction is forward. It's not a law like gravity, it's more of a statistical truth, a trend the universe prefers, and it is incredibly persuasive. Even you, lying still now, are part of this unfolding. Your body sheds heat, your thoughts wander. The very act of sleeping is part of time's gentle push. Entropy isn't chaos, it's natural aging, the loosening of order. And in this way, entropy gives time its shape. Without entropy, there would be no before and after. No reason not to rewind. But with entropy, the world remembers where it's been. The smoke doesn't return to the fire, the wave doesn't fold backward into the sea, and the child doesn't become unborn. There's something beautiful in that. Something bittersweet. The past is fixed, untouchable, safe. The future is open, unknown, waiting, and here you are, in the now, the only place where action lives. Now let's imagine a room. A warm room, with a hot cup of tea on the table. The tea steams. Slowly, gently, the warmth escapes into the air. Soon the tea cools. Could it warm up again on its own? Not likely. That heat has already spread. Entropy has increased. The room, the tea, the air, they've moved forward. In every moment these little unfoldings add up. They give direction. They make time feel like time. Even your memories are built upon entropy. You remember the past because your brain recorded it at a lower state of disorder. You can't remember the future because it hasn't taken shape yet. And your dreams? They're built from rearranged pieces of the past, never the future. So here's something gentle to hold on to. You move forward in time because the universe is unfolding, like a blooming flower, like music stretching from the first note to the last, like pages turning, each one written only after the last is read. And that motion, though irreversible, is not cruel. It gives life its shape. It gives meaning to growth, to learning, to healing, to moments that pass and memories that stay. So when you feel time slipping, remember, that slip is the song itself. Without it, there would be no melody. And even though the past is gone, it isn't lost. It's layered into you, like rings in a tree, like echoes in a canyon. Entropy never erases the past. It just writes new pages. And so you sleep as the universe gently rearranges itself around you. The heat moves, the stars burn, the seconds stretch, and you, a quiet collection of moments, ride the arrow of time forward. But one last thought drifts in. If we can't return to the past, not through any known path, can we see it? Can we look up and find the past shining down upon us? Night has deepened, and the stars are out. You might not see them now, your eyes gently closed, your thoughts floating inward, but they are still there, whispering across the vastness of space, and they are not shining in real time, they are reaching you from the past. This chapter begins not with motion, but with stillness, not with science fiction, but with a gentle truth. When you look at the stars, you are looking backward in time. Let's drift upward together, out of your room, above the rooftops, past the quiet clouds, into a sky thick with stars, billions of them, burning, turning, distant. Some are close like Alpha Centauri and just over 4 light years away. Others sit at unthinkable distances, hundreds, thousands, millions of light years from Earth. And yet, here they are, shining down upon you. But the light you see is not from now, it is light that left long ago, because light, for all its speed, is not instantaneous. Even at 299,22 kilometers per second, it takes time to travel, and in space that distance stretches across years. So when you gaze at a star, you're not seeing it as it is, but as it was. You're seeing its old light, its past. Imagine this. You look at a galaxy. So far away its light took 100 million years to reach you. That means, as you gaze upon it tonight, you are witnessing its ancient state, a glow that began before humans existed, before mammals walked the earth. The star you see now may no longer exist. It may have burned out long ago, but its light, its final echo, is still crossing space, still arriving, still telling its story. And this is the quiet magic of starlight. It makes the universe a natural time machine. We don't have to build one, we live inside one. Light carries the past to us, like messages in bottles thrown into a black ocean, drifting for millions of years before washing up in the shore of your eye. Now let's go even deeper. Astronomers use telescopes not just to see farther, but to see earlier. The farther we look, the longer the light has travelled, the older the image becomes. Modern observatories capture galaxies as they were billions of years ago. Some of the earliest light from the birth of stars, from the formation of clusters, from a time when the universe was young, hot, and full of potential. That light is still moving, still unfolding. And we, on this tiny blue planet, catch it with mirrors and sensors and wonder. The light that touches your skin during the day left the sun 8 minutes ago. That warmth is not from now, but from a moment in the recent past. The moon, too, reflects light that began at the sun, travelled across space, bounced from stone, and reached your eyes with just a breath of delay. In space, nothing is truly now. Everything you see has already happened, and time through light reaches you gently. There's something comforting in that. The past is not lost. It lingers. It glows. It keeps coming. And not just across galaxies, but across lives. A photograph. A memory. A voice recorded. These are echoes. Not starlight, but human light, travelling forward in their own way. So tonight, even as your eyes are closed, you are surrounded by stories of long ago. The light of dead stars, the warmth of minutes past, the hush of ancient photons softly touching the earth. You yourself are glowing too. Your body gives off infrared light, a quiet heat that travels outward. You're part of the web of radiant time, a sender, a receiver. You exist inside light's journey, and as you rest, you can imagine it. The sky above you not as a ceiling, but as a map of time. Each point a moment, each star a memory, each shimmer a traveller still on its way. And if we can see the past in the stars, what about here on Earth? Does your own experience of time shift, change, bend, even when the clock stays steady? Why do some moments feel long and others disappear? Can time flow not only differently in the universe, but inside you? Time is not always what it seems. Sometimes a minute stretches so long you could swear it was an hour. Other times, an entire afternoon vanishes like breath on glass. You look at the clock and only 5 minutes have passed. Or, suddenly, the day is gone. Why does this happen? Why do some moments feel thick and slow while others melt away before they even form? Tonight, we explore time not as it is, but as you feel it. Because while physics may define seconds precisely, your experience of those seconds is shaped by something softer, your mind. Let's begin at the beginning. You're a child playing in the sun. A day feels enormous. Summer seems to last forever. Each experience is new, each sound, each sight a discovery. Your brain records these moments in rich detail, and the more there is to remember, the longer the moment feels. This is one reason why time seems to speed up as we grow older. Not because it moves faster, but because we process less of it. Familiar routines, known patterns. The brain compresses what it already understands. It doesn't need to store every moment, and so time appears to rush. But novelty, new places, new people, new sensations, slows perception. It fills time with texture. Even the brain's chemistry responds. When adrenaline spikes, like during a surprise or a scare, your mind sharpens. It samples time in finer detail. This is why accidents often feel like slow motion. Your body reacts fast, but your brain is recording more frames per second, stretching each moment. So in a way, your brain is like a camera, deciding how many pictures to take. More pictures? Time feels long. Fewer? Time slips by. Now imagine the opposite. Boredom, a waiting room, a silent elevator, a slow afternoon. Each second feels like it drips. Your awareness focuses on time itself, and because you have little else to engage, you feel every passing drop. But afterward, when you look back, those moments blur. They leave little behind, and so in memory they feel short. So we live in a paradox. When time feels slow in the moment, it often feels short in memory, and when it flies in the moment, it stretches long in hindsight. Now let's drift inward, into the rhythm of the brain. Inside your head, tiny circuits keep the track of passing time, but there is no master clock, no single ticking metronome. Instead, time arises from the synchrony of movement, attention, emotion, and a memory. When you're fully focused, engaged in a task, in a moment of flow, time disappears. You don't feel it pass. You simply are. And then, you look up. Hours gone. This too is time's trick. It vanishes when we are immersed. It reveals itself only in absence. So how you feel, what you do, even what you eat or hear or think, all these shape your time. Even your heart contributes. Studies show that when your heart rate increases, your perception of time changes. A racing pulse can make moments feel longer. Pain stretches time, so does fear. But calm shrinks it. Sleep too plays its part. You fall asleep and dreams begin. In dream time you may live a whole day or experience only flashes. You awaken and the night has passed. But how long did it feel? You don't really know. Time in the dream didn't flow like water. It appeared, rearranged, and slipped away again. Even your circadian rhythm, your biological day-night cycle, affects how you perceive time. When your internal clock is well aligned, you feel in sync. Your sense of time smooths out. But when that rhythm is disturbed by travel, shift work, insomnia, time can become disjointed. You lose track. You float. This is why sleepless nights often feel long, but hazy. The brain, unfocused, holds time loosely, and in states of deep meditation or grief or love or awe, time can vanish altogether. In such moments you are not watching the seconds. You're within them. You're not outside time, you are time. So when you say, "I don't know where the time went," you're not wrong. You didn't lose it. You simply weren't holding it. And yet time left something behind. A feeling, a memory, a trace of your presence in that passing stream. Now, as you lie still, your breath slow and soft. You're sculpting time in your own way. You are the artist, the witness, the dreamer. You decide what stays, what expands, what vanishes. Time is not just outside you, in clocks, in stars, in orbits. it's also inside you, in neurons, in rhythms, in the soft story of your attention. And that means, in a very real way, you shape your own hours. Not the number of them, but their meaning, their weight, their colour. So sleep now, knowing you are not merely passing through time, you are giving it form. And if we as living beings can shape time from within, what about life beyond us? Are there creatures, or even places, where time moves even more slowly? You are resting now, drifting gently in the slow tide of sleep. Time in this moment feels softened, not erased, but quieted, and far beyond you, beneath oceans, beneath stars, in places of pressure or silence or ice, other beings, living and not, experience time in their own slow way. Not through science fiction, not through fantasy, but through biology, through physics, through resilience. Tonight, we visit them. Let's begin beneath the waves. Deep, deep down, far below where sunlight fades, where the sea becomes black and still, there lives a creature small enough to fit between grains of sand, and tough enough to outlast almost anything. The tardigrade, also known as the water bear. It walks slowly, it lives simply, and when conditions become harsh, when water vanishes or radiation spikes or ice begins to form, it stops, it folds itself inward, shrinks, seals, becomes almost dry. In this state, called cryptobiosis, its metabolism slows to a near halt. Time for the tardigrade almost freezes. It can survive for decades in this way. No food, no water, no motion. And then, with a drop of warmth, a flicker of moisture, it returns, alive, unrushed, unbothered. This is not immortality, it is patience, a different tempo of life. Now let's rise again into the quiet orbit of space. Here on the International Space Station there are seeds, spores, and tiny life forms that float for months, untouched by atmosphere, some surviving radiation and vacuum better than machines. Again, not because they are fast, but because they are slow, because they can pause, because they do not resist time, they step out of it. Even some plants, frozen in ancient peat bogs or polar soils, have seeds that sprout after thousands of years. They waited, and waited. Time for them was not a steady river, but a shallow pool, touched only when needed. But it's not only life that experiences this slowness. In the world of physics, some particles move through time in almost unimaginable ways. Consider the proton, a building block of all matter. Stable, steady. It can last for eons. In fact, if it decays at all, its half-life is longer than the age of the universe. That means the protons in your body may have existed since the first stars were born, and they may still exist when all the stars have faded. You are built of slow time, even in the stars themselves. Some processes unfold across billions of years. Stars age slowly. Their nuclear engines burn not with haste, but with deliberate grace. A neutron star, the collapsed heart of a massive supernova, spins rapidly, but ages glacially. It will cool over trillions of years, drifting slowly into darkness. Time for such an object moves with the heavy breath of the cosmos. And there are black holes that may outlive everything, still present as the last embers of a long unfolded universe. In all these cases, from microbes to matter, time is not denied. It is simply met with quiet. So what does that mean for you? You who breathe and sleep, who live in a world of hours and years and alarms. Can you ever slow time? Perhaps not in the literal sense, but you can shift your rhythm. In moments of stillness, in meditation, in awe, in love, you felt it. The slowing, the widening, the sense that time has paused just long enough to let you notice its breath. Even your body in deep rest repairs itself more efficiently. Healing, renewing, slowing. You're not built for stasis, but you are built for rhythm. And rhythm means sometimes fast, sometimes slow. So tonight, as you lie still, know that you are allowed to move gently through time. You don't need to race. You don't need to rush. Even the oldest stars move slowly. Even the smallest creatures take their time. And if they can, so can you. And as you drift deeper, one last question follows you. If time can be slowed but never truly reversed, what would happen if we tried to walk backward? What if we turned around in time? What paradoxes might greet us? You are still now, breath even, heartbeat slow, mind open. Tonight we walk softly into a question that has stirred imaginations for centuries. What if you could go back, not just remember, but return to an earlier moment, a forgotten morning, a time before something was said or done or lost? What would happen? Would time welcome you? Would it resist? Let us enter, now, the gentle landscape of paradox. Start with a thought experiment, simple and ancient. You travel back in time. You meet your younger self, or your parents before you were born. Now imagine you do something small. Change a word, a glance, a moment, and suddenly the future shifts. Your future. Maybe in this new future you were never born here, but then, who travelled back? This is the heart of the grandfather paradox. If your actions in the past prevent your future self from existing, then how could you have gone back at all? A knot forms. A logical loop. Cause and effect chase each other's tails. It's strange, unsettling, and deeply fascinating. So physicists began to wonder, can time allow this kind of return? Not just practically, but logically. Some say no. They argue that any timeline that allows you to undo your own origin would collapse under contradiction. Others propose a softer answer, that time, like water, reroutes around disruption. This leads us to the idea of self-consistency. If you were to go back, you could act, but only in ways that support the present you already know. You wouldn't be able to prevent your birth because your very presence proves it already happened. Like trying to edit a story while still reading the same printed page. In this view, the past is fixed, even if visited. And then there's another possibility, one of the most poetic, the many worlds interpretation. You go back, but in doing so you don't alter your own timeline. You create a new one, a branch, a separate thread. You aren't changing your past, you're entering someone else's. And from there a new future grows, one where you may stay, or leave, or vanish altogether. In this view, paradox dissolves, because each possibility exists somewhere, in its own quiet lane of reality. But these are ideas, not realities we can test, because no matter how we dream it, no one has travelled back through time, at least not that we know, and physics, as we currently understand it, does not permit closed loops in time without encountering enormous problems. Energy, causality, entropy, even wormholes, those curious theoretical bridges through space-time, face barriers that make time travel nearly impossible. They collapse. They require exotic matter. They may not allow information to survive the trip. Still, they haunt our minds and our stories. Because the longing to return is deeply human. To say something differently, to stay longer, to undo a wound, to touch a moment one more time. But perhaps it is not about changing the past. Perhaps it's about making peace with it. Because in a way you are a time traveller. Every time you remember, every time you listen to an old song or hold a faded photo, or feel a smell bring back childhood, your mind moves through time, not physically, but emotionally, intimately. And no paradox arises, because you do not change the past. You carry it. You add layers. You create meaning. You bring the past forward with you, woven into your breath. So while the machine remains fantasy, the feeling is real. Now imagine this. You could speak to your past self. Not through time, but through kindness. What would you say? You made it. You're learning. You're still here. That message may be all time travel ever needs to be. A reminder that the path you've walked was always yours, and forward is the only way. So tonight, as you dream, know this. You are not trapped in a single thread. Your choices still shape the next hour, the next day. Time may not bend back for you, but it stretches forward endlessly. And perhaps that's the truest freedom. Because even if the past cannot be changed, the meaning of it can. And as you turn toward tomorrow, a softer question begins to stir. What if time itself isn't fundamental? What if it's not a river, or a fabric, but an illusion? Could it be that time isn't something we move through, but something our minds create? You lie here, quiet now. The world around you fades to a hush. There is no rush, no need, only stillness. And into this stillness comes a soft, curious idea. What if time, this thing we live within, watch pass, mark with calendars and clocks, isn't actually real? not real in the way rocks are real or sound or light? What if time is an illusion? It sounds like fantasy, but it's a serious question. One some of the world's most thoughtful physicists are beginning to ask. Let's drift into it gently. Start with change. We notice change. We feel it. A leaf turns brown. The moon grows full. Your breath rises and falls. But do we see time itself? Or do we see change and infer time from it? Think of a movie. On the screen, things move, scenes flow, moments evolve, but behind the scenes, it's just a series of still frames. No motion, only a collection of images, shown one after another. The motion you perceive is your mind filling in the gaps. Could the same be true of time? That what you feel as flow is really a string of moments stitched together by memory and awareness? Some physicists think so. They call this the block universe, a picture of reality where past, present and future are equally real, all existing at once. You in this view are like a traveller on a train moving through a landscape that is already there. The town you passed still exists, the one ahead already exists too. Your experience of now is simply your window, your perspective. In this universe, time doesn't flow, it is. It's like space doesn't move, but you move through it. And if that's true, then the feeling of time passing might be a trick of consciousness, a result of how your brain strings memories together to make meaning. Neurologically, there is no single place in the brain where time lives. There is no internal clock that defines it absolutely. Instead, you experience time through rhythms, through cause and effect, through order. You construct time the way you construct stories. One event, then another. A beginning, a middle, an end. So what if time isn't fundamental at all? What if underneath it there is only change, or even more deeply, only relations between things? This idea echoes in some corners of quantum gravity, where time disappears from the most basic equations, where what is matters more than when it is. In these models, the universe may be described not by timelines, but by states, snapshots of possibility, woven by laws of symmetry and interaction. And you, a being made of particles and perception, create your own version of time as you move through those states. Even in quantum mechanics, the moment you observe a system, you collapse its wave function into a single possibility. Before observation, there was no change, just a cloud of potential. No time, only probability. And so time in this view emerges when you interact, when you notice, when you remember. Not something outside you, but something made by you. Now let's come back to your own experience. Think about a moment when time disappeared. In deep sleep, in meditation, in awe. When you were fully present, not thinking of what came before or what would come next, time vanished. But you didn't. You remained. So perhaps time is not the ocean you float in, but the wake your boat leaves behind. A record of movement, a story of motion, a pattern your mind calls time. And this idea, as strange as it sounds, doesn't make time meaningless. It makes it more precious. Because if time is something we construct, then every moment is a small act of creation. Every memory, every expectation is you shaping the world's rhythm from within. And so, even if time isn't real in the strictest sense, it's real to you. Real enough to shape lives, to grow gardens, to say goodbye, to fall asleep and wake up and fall in love. So don't be afraid if time turns out to be a mirage. You live in the story of it, and your story is still unfolding, even now, and one last question lingers in the quiet. If time is not fundamental, then what is? What lies beneath it all? Could space and time both be born from something deeper, more hidden? A kind of quantum threadwork that we've only just begun to see? Tonight, we let go even more. Of clocks, of calendars, of time as something steady and linear. Instead, we drift down, beneath time, beneath space, into something more subtle. A gentle weave, a whispering net, a fabric not made of threads, but of relationships. This is where modern physics begins to dream. That space and time may not be the foundation. That beneath the surface of all things is something even more elemental. The quantum world. Let's step into it carefully. Imagine the world not as a grid, but as a cloud, a soft haze of potential. Particles don't exist as single solid things. They exist as waves of possibility. They can be here or there or both. They flicker, they wait, and only when you observe them do they choose. This uncertainty isn't a flaw, it's a feature. At the smallest scales, the universe doesn't commit until it has to. Now consider this. If particles exist in clouds of maybe, then what about space itself? What if even the fabric of space is not a smooth sheet but a collection of relationships? In this view, space and time emerge from the way things are connected, from how they interact. Think of it like this. Instead of space being a stage on which particles perform, the performance creates the skeptives. This is the heart of quantum gravity. The idea that time, space, motion and shape emerge from deeper processes that don't look like anything we've seen. Some physicists picture it as a spin network, a web of connection, tiny loops and threads, braided together at the smallest scale. This is not the fabric of space-time, but its loom. Each node in the network is not a place, it is a relationship. And the geometry of space, even the ticking of time, comes from how these nodes are arranged. You might never sense this directly. The world you live in is already smooth, already macroscopic. But in the quiet heart of reality, the universe may be woven not from matter, not from time, but from information, from connection. Now, let's float back to a phenomenon you've heard before, quantum entanglement. Two particles linked across distance so that a change in one is reflected instantly in the other, no matter how far apart, even across galaxies. Einstein called it spooky action at a distance, but it's not magic. It's the universe revealing that space, and maybe even time, are not as separate as we think. Some scientists now believe that space itself may be made from entanglement, that where there is more entanglement, space stretches, and where there is less, it shrinks, like weaving a net. The more tightly it's tied, the stronger the shape. So what does this mean for time? It means time might also emerge from these relationships, from how things change relative to one another, from the evolution of patterns in the network, from the updating of information from one moment to the next. Not a river, not a ticking, but a kind of computation, a story unfolding step by step, not in seconds, but in state transitions. In this view, you don't ride through time, you are part of the process that creates time. Every choice, every breath, every observation updates the state of the universe. And from that, a moment emerges. A now, and another, and another. The flow of time then may not come from some external beat. It may come from within, from interaction, from awareness, from being. It's hard to picture, it's hard even to feel, but it's possible that what you experience as time is just the unfolding of relationships between everything. So when you move your hand, or blink, or think, you're not moving through time, you're helping time to exist. This is a radical idea, one that we don't yet fully understand, but it points to something beautiful, that underneath the fabric of space-time is not emptiness, but connection, that you're not separate from time, you're part of its origin, and maybe, at the deepest level, the universe is not a place but a process, not a structure but a song, a quantum song sung softly by loops and links and possibility, and you are one of its notes. Now rest. You don't need to hold all this, you only need to float in the warmth of wonder. Tomorrow may bring more questions, sure, but tonight, you are part of the answer. And as you sink deeper into sleep, let this final thought drift across your mind. If time and space are born from quantum threads, what then is now? Is there one true present? Or are there as many nows as there are eyes to see them? Now, a small word, a slippery word, a word you use every day without fully knowing what it means. You live in the now, you breathe in it, you act inside it, but when you try to hold it, it slips through your fingers like water. Because by the time you say now, it's already gone. So, what is now? Is it a single shared moment, the same for everyone, everywhere? Or is it something more local, more personal? And is now a feeling, a place, a perspective? Tonight we follow that question into the quiet heart of time. Begin with your body, your senses. You see light, you hear sound, You feel the weight of the blanket, the rhythm of your breathing. But these signals don't arrive at once, and your brain, in its quiet brilliance, delays your awareness just slightly to synchronize them. What you call now is not an instant. It is a small window, a pause, a blend. Researchers suggest your conscious present may be about 3 seconds wide, enough time to notice, to feel, to respond. Your now is already an interpretation. Now expand outward. Imagine two people miles apart, one on a mountaintop, one in a valley. A flash of lightning strikes in the distance. Did they see it at the same moment? No. Light takes time to travel. Each observer sees the strike at a slightly different now. Their nows don't align. And relativity tells us this goes even deeper. Einstein showed that there is no universal clock, no master timeline. Time stretches and bends based on speed and gravity. What is now for someone on a fast-moving spaceship may be later for someone on Earth. Even two people passing each other on the street carry different versions of the present. So now is not absolute. It's not written into the fabric of reality. It is carved out by perspective. We live in overlapping news, each one local, each one a little universe of experience. Your now is stitched from where you are, how you move, and who you are. But that doesn't make it meaningless. In fact, it makes it sacred, because this moment, or the one you are living in, is yours. It is born of your breath, your senses, your awareness. And in it, you are most alive. Even as the future approaches, even as the past lingers, now is where your choices happen, where your attention flows, where you meet the world. But what happens to now after it passes? It becomes memory, not the cold storage of a camera, but a living thread in your mind. You don't remember all your nows, only some, and those you keep become part of your story. A smell, a song, a glance, all of them, once moments, now folded gently into who you are. So the meaning of now is not in its precision, but in its presence. It's the space where life unfolds, where perception touches reality, where feeling happens. Even in sleep, your body holds on to now. It repairs, it sorts memories, it dreams. Each heartbeat, each breath, a tiny echo of presence. And even when you're lost in thought, worrying about the future or reaching for the past, you do it now. There is no other time you can do anything in. Now is not a place you visit. It is the only place you are. So rest easy. You don't need to chase the moment. You're already inside it. And though now never stays, another always arrives. You are gently carried forward by a string of present moments, each one just as real as the last. Now becomes memory. Memory becomes meaning. Meaning shapes who you are. And so time becomes a spiral, not a line, not a loop, but something richer, something that holds you without needing to hold still. Tonight, let your now soften. Let it be wide enough to hold breath and thought and wonder, and let it stretch into the next soft mystery. If time can carry meanings and now can shape who we are, what does that make us? Are we passengers in time, or are we time itself, briefly aware of being? Tonight, we arrive not at the end of time, but at the edge of understanding. The edge where science becomes wonder, and thought becomes rest. You've followed time across stars and particles, through memory and mystery. And now, as you rest even deeper, one final question floats forward. Are you simply a being in time, or are you a being of time? At first, the difference seems small. A being in time moves through it, watches it pass, is shaped by it. This is how we often think of ourselves. Riders on a current, carried from birth to breath to silence. But there's another view, softer, slower, deeper. A being of time is not just moving through it. It is part of what gives time shape. It lives as a process, a rhythm, a flow of awareness and chen. You're not just in time, you're time as lived from the inside. Just as a melody is made of notes, but also becomes something more when it's played and heard, so you're made of moments, but become something more as you move, feel, remember, and dream. Your thoughts do not happen in time, they create it. Your experiences do not unfold inside a schedule. They form the very sense of passing, and your identity, who you are, is not fixed in one instant, but is stretched across a story made of time, but also making time. Even your sleep, which now cradles you gently, is not a break from time. It is a different kind of time, a healing time, a dreaming time, a time when the world softens and the inner universe stirs. You're not outside the fabric, you are woven into it. Your memories are time's echoes, your hopes are its compass, your breath is its beat. And so this final question becomes not just cosmic, but deeply personal. When you feel time pass, you are not just observing, you are participating. And when you speak, when you love, when you rest, you are helping time to be. You're not a watcher, you're a contributor. Even now, as you lie quiet, the story of time continues, not in stars alone, but in you. A thought drifts by. Maybe it's not, I am in time. Maybe it's I am time, a thread of the great unfolding. And if that's true, then rest is sacred. Silence is beautiful. And sleep is not absence, but deep participation in the rhythm of being. So rest now, gentle traveller. Not because time stops, but because your part in its song softens for the night. You're not led or late. You're not behind. You're precisely where you are meant to be, in the moment you helped shape. The stars continue their drift. The earth hums beneath you. And you, softly glowing with life, drift into the next line of the melody. Thank you for being here, for walking with time, for dreaming through the deep questions. And if this journey brought you even a breath of peace, a ripple of wonder, a quiet place to rest your thoughts, I'd be so grateful if you gave this a gentle like, maybe even subscribed, shared it with someone else who needs calm, or left a comment below telling me where in the world you're listening from. Your voice is part of the rhythm too, and your kindness helps this little space of science and stillness reach more sleepy minds around the world. And if you feel called to go further, to help support what we're building here, a super thanks is always a cherished gesture that helps me keep creating these stories just for you. But for now, breathe, sleep. Let yourself dissolve gently into the time that holds you. And stay tuned for our next quiet journey together in another bedtime story of calm curiosity and the beautiful universe you're part of.